for the earlier presentations. I really enjoyed them and I benefited. And I do hope students have also benefited from your presentation. Thank you so much. Mr. Chitimbe, please can you help me with presentation rights?
You have got the rights, Mr. Kanyongo. You can upload your work.
Okay, thank you. Let me try to share my screen and do it via the share screen. Okay, confirm you can see my presentation.
It's still coming up.
Still coming up.
Yes, you can see.
Okay, so let me start by answering a question that I'm seeing on the public chat. Another student is asking, can they be able to have an audio? Can they have an audio download? And you had answered it and said you are going to send them a link, and actually they can use the same link after some time to access the recording. Confirm, Mr. Chitimbe?
Yes, in fact, even by the end of the day, they can do a playback through the same link.
Okay, fine. So I think the student is answered. So I'm presenting, and this presentation will help specifically the students from Big Data Analytics, and also even students from other domains are going to help to benefit from my presentation. And I've titled my presentation a roadmap and building blocks for data science research. And as we progress, I will begin by breaking down the key terms so that you benefit from the subsequent presentations in the subsequent slides. And maybe I will zero in on the artifacts because when it's a data science research, what we want to see at the end of the tunnel is an artifact. So I will zero in on what we refer to as an artifact and what are our expectations. And I also look at the foundational elements which have been covered, but emphasizing on some strains which, and I will touch on certain elements that I think will also add value to a data science research. And a little bit of literature review on those additions that I think will help the data science, the big data analytics students, and the methodological aspects of a big data analytics research. And I also bring to the fore how do you choose a maybe choice of an algorithm and locating or generating a data set for your research. And I'll also look at the overall dissertation structure or layout. It has been covered, but I'll also emphasize one or two things. Referencing has been covered, formatting a little bit, and required big data analytics or data science skills, and the tools that you need to make use of as you undertake your research. The do's and don'ts, and I'll give you time to ask questions. Now, for me to be effective in my presentation, let me break down the key terms and what do we mean by a dissertation? A piece of academic writing centered around original research. What you need to take away there, it is centered on original research. And what are you doing? You're developing a unique and original concepts in a particular field of research with unique hypotheses and approaches. Some of those things have been mentioned. So you go through extensive literature review, you go through the methodological aspects, data collection, analysis, and discussion of the results. And this is a substantial paper, a dissertation. At the end of the day, the report that you are going to put across is typically based on original research, and that gives evidence of the candidate's mastery, both of her own subject and of scholarly method. So we are going to, so this assertion, this phrase means you have to lift the game to writing a successful dissertation. Do more of better reading and research than for a standard undergrad essay. So this is more than an essay. Just a moment, we are sharing this office, so they're asking me something here. Okay, so we can continue. We have another department that is also running something from this end. Okay, so we want you to display precision and skill in your modeling and development work. And we expect you to give evidence of your data science research. And what we are expecting from the data science aspect is an artifact, and we should suck you into this. Understand that we require you to produce an artifact through your research. And what is big data analytics? It refers to the process of collecting, examining, and analyzing large and varied data sets. We call this big data. And you are to uncover patterns, correlations, trends, preferences, and other useful information that can help organizations and managers make more informed business decisions. So you are going to see that when it comes to a big data analytics research, you are combining several disciplines. And this might include statistics, computer science, and data engineering. And you often employ advanced tools and techniques such as machine learning, predictive analytics, data mining, and artificial intelligence. And the goal is to turn complex and massive data into actionable insights. And if I may skip that one, and that one, I think that information on what is data, you should be okay. And we are going to talk more about a data set. And the data set is a collection of data typically organized in a structured format, which can be used for analysis, research, and various applications. So you are going to see that in as much as we say your research is anchored on a problem statement, from a data science research perspective, you must locate a data set, or you must generate a data set as one of your preliminary efforts in undertaking this research journey. So data set is very, very important for you to have. So it might be structured, it might be unstructured, it might be raw data that you need to work on, transform it to make it amenable for analysis. So it can be text, it can be images, it can be audio, it can be video, it can be textual data, it can be numbers. What we want at the end of the day, we want a data set that suits what you want to address. And in a data set, what you have a structure of the data set. Is it organized or is it not structured? And it has variables, which might be the attributes or the columns in a data set. It might be records or observations, which we can call rows or tuples, representing a single data or instant. Or it could be metadata, data about data, describing the variables or the units of measurement or data collection methods. This is data about data, the metadata. So let me zero in on what we want, what we mean by an artifact. An artifact refers to the tangible outcome that students have to make in a project. You are going to produce a tangible outcome at the end of your research. So in your topic, in your objectives, what we want you to have at the end of the day, what we want you to have at the end of the day is an artifact. And let me give you examples of the artifacts that we are expecting from you, and this might help you even to model your topic. It could be a data visualization or data visualizations, which are graphical representations of data designed to highlight key insights and trends. I know some of you have done some courses where we are talking about creating interactive dashboards using tools like Power BI, Tableau, to visualize maybe sales performance across different regions. So you might have that interactive dashboard or dashboards, and that's an artifact from a data visualizations point of view. It can be a machine learning model. A machine learning model, trained models that can be used to make predictions or classifications or clustering, solving a regression problem or an association problem, and so on. So it can be a machine learning model. So you are going to see that your supervisor are going to be asking you in your topic, what are you going to give us at the end of the day? Is it a model? What kind of an artifact are we expecting to get from your research? Is it a machine learning model? Is it a deep learning model? Is it a reinforcement learning model? Is it a transfer learning model? So understand that we want an artifact, and I want to suck you into this because it's critical. Maybe one use case, maybe scenario, you might develop a predictive model to forecast stock prices. So the artifact would be the trained model, which can be deployed to make real-time predictions based on new data. Take that home. Another artifact. I know one thing that is difficult for a data science student is to identify an area where you can undertake a research or to model a topic. And if you are listening closely, I'm telling you, you are going to benefit in as far as the formulation of a topic is concerned or choosing an area of research is concerned. So data pipelines. So what we can have as an artifact can be a data pipeline, which is an automated workflow that process and analyze data from raw input to final output. And a use case, a scenario could be building an ETL, extract, transform, load pipeline that extracts data from various sources, transforms it into a consistent format, and loads it into a data warehouse for analysis. I know you did a course data warehousing, and you exposed it to ETLs, to data warehousing, to scripting, and so on. An artifact can also be in the form of a software tool or script. A software tool or a script. So this can be custom software applications or scripts developed to perform specific data-related tasks. We can see you building a Python or creating a Python script that automates the pre-processing of text data for natural processing language processing tasks, and the script would handle tasks such as tokenization, stemming, and removing stop words. I'm just giving you hints of some of the artifacts that you can produce, so that we run away from the tradition of just producing machine learning models, but you can also even produce these other artifacts. Data sets. This can be part of the development of a model, a machine learning model, or an intelligent agent, or full-fledged, you want to create a data set, which we call a curated and cleaned data set that can be used to further analysis or model training. So what are you doing? You might be publishing a cleaned and annotated data set of customer reviews for use in sentiment analysis. And this data set would be shared with the research community or used internally to developing new natural language processing models. In this year, I think 2024, I created a generated data set in a data paper which I published in Data Intelligence, which falls under the MIT Press, Massachusetts Institute of Technology, and the paper is entitled Data Wrangling and Generation for Machine Learning Models in Medication Adherence Analytics, and that was from a practical standpoint using patient level and the medical claims data. So you can also do the same, or as part of your thesis, maybe as one of your objectives. We can see you generating a data set and you are contributing to the universal body of knowledge. And if you want to access this data set, you can see that reference that I've posted on screen. And if you want to make use of my data set, you can actually go on Mendeley data, and that is the link. You can access the dataset link. If you happen to go through my paper, that one, you see that I've documented a set of steps that I took in the generation of that paper. And you can also benefit if you are to generate a dataset for your research. So we are also these days generating datasets and writing data papers, and by so doing, you are contributing to the universal body of knowledge. Number 6, you can have an artifact.
Mr. Kanyungo.
Yes.
Are we going to have this slide? I'm not in data analytics, but I would like to have this slide, the one that you are presenting. Is it possible to get it?
Yes, through the same link you can get the recording.
No, I want the slide, not the recording.
Oh, the slides.
Yes, I'm particular.
Okay, so via Mr. Chitimbe you will get.
Thank you, sir.
Via the administrator you will get. Okay, so you can have an interactive application, a user-friendly application that allows stakeholders to interact with the data and models. And I have my undergraduate students developing a machine learning model. And on top of that machine learning model, they develop an application, which means it's feeding into an application. On top, they are building an application, which by nature, it becomes an intelligent application because it's built on a machine learning model. So you can do that. For a serious student, surely 6 months is a lot for you to develop a machine learning model or models. Then on top, you have an application, an intelligent application that is drawing from that machine learning model, and you are having an interface or a set of interfaces which where we can be using that application maybe for a particular domain. In this case, you can develop an interactive web application that allows users to input various parameters and see the predicted outcomes of a real estate price prediction model. So this application would be useful to real estate agents and potential home buyers. So I'm giving you also the practical scenarios so that you'll be able to picture and follow. Because from a data science research perspective, students are having a challenge of formulating a new topic, a topic that will bring up maybe a novel model or application or system. We are seeing we are seeing a recycling of topics, a repetition of topics in this yesteryear being carried forward even in this current semester. So it can be an algorithm. So I know you did machine learning as a course, and there are many machine learning algorithms that you were exposed to. Talk of SVM, support vector machines, talk of k-means, talk of k-nearest neighbor, talk of an artificial neural network, talk of another algorithm. As a data science student, you can actually develop your own algorithm, which is a defined procedure or a set of steps to perform a specific task or solve a problem. So we can actually have an algorithm developed by our student, and you give it your own name, you name it, and the other students, future research practitioners, will actually benefit from the algorithm that you would have developed. So this is one thing that you can also do. This can be algorithm that can be implemented in code and form the backbone of data processing and analysis, maybe in future research work. I hope you are taking this down and you are noting this, and we'll see if we can have students who can go to this extent. Another way of developing an algorithm, an artifact in the form of an algorithm, you might be saying, I want to have a hybrid of existing machine learning algorithms. Then you twin the algorithms and you have a hybrid, which you would then test maybe on a particular data set, and you see if you can perform when you compare it with the classical or the traditional machine learning algorithms. So we want to see students even maybe making use of hybrid machine learning algorithms. Now, an artifact can be an intelligent agent which is an autonomous entity that uses data to make decisions, learn from interactions, and perform tasks in dynamic environments. So you can develop a recommendation system for an e-commerce platform. This intelligent agent would analyze user behavior, preferences, and historical data to suggest products that users are likely to purchase. So you can come from this angle and develop this kind of an artifact. Let me zero in on the foundational elements. They've been covered, but I wanted to highlight, to make some highlights on specifics that apply to a data science research. So I'll cover something to do with the research topic, some of things that we expect in a background to the study, but not staying long on that. Even a problem statement and objectives, significance of the study, it has been covered extensively, and scoping of the study has been covered extensively as well. So one thing that I want you to take home, you have the understanding that data science research topics are indeed interdisciplinary and multidisciplinary in nature. So what are we saying? You are seeing a convergence of various domains in solving maybe a single problem. Let me emphasize this point. What is making our students to recycle topics? What is making our students to repeat work that has been done before is that they are not understanding that you can actually break new grounds. Break new grounds by merging two different domains, even three, even four, and when you bring these domains together, these disciplines together, you can be able to address a research problem or a research question. Let me throw up a practical example. Like we talk about computational biology. So this field lies at the intersection of computer science, biology, and mathematics. And we can see one of our students developing an algorithm or algorithms for DNA sequence alignment and analysis. Or we can actually see you applying machine learning approaches to predict protein structures or identify disease-causing genetic mutations. And you see that there is computer science with programming, there is biology in play, and the statistics in play. And what are you having? We are having that convergence to solve a real problem. Let me give you an example, because this is where research topics are born. I want you to take I want you to take note. You can be able to create or to develop topics from the next 2 or 3 slides that I will be presenting on. Let's talk about urban planning and smart cities. You will see data science playing a critical role in understanding and improving urban environments. And as a researcher in this domain, you might utilize sensor data and satellite imagery to analyze traffic patterns and optimize transportation networks. And this, I think, speaks to our environment where we are having challenges of congestion, and we can actually have one of our big data analytics students coming with a research that can address this problem at hand. So we are seeing an intersection of sensor networks, or we can talk about the IoT, Internet of Things, geoinformatics, traffic engineering, or urban planning. So convergence of these disciplines can be used to address the problem that we have at hand. So it can be designing predictive models to forecast energy consumption and improve resource allocation in smart cities. You agree with me that we are having an energy problem, not only as a nation within our national borders only, but even beyond our national borders, there are energy challenges. And a student come in, and what are you doing then? The research is interdisciplinary. In what way? Maybe we can have the computer science aspect there, urban planning there, environmental science there, civil engineering there, economics there, data science there. And you do this, I'm telling you, you will come up with very good topics that address real problems in our communities. We can also develop predictive models for stock price movements or financial risk assessment. And when you have such a topic, you are bringing together disciplines such as finance and economics, computer science, data science and analytics, business and risk management, and you are going to say that in as much you might be conversant with the data science, maybe tools, skills, and systems, but you might also require to go a step further to gain domain-specific knowledge, because you are applying data science in a particular field or domain. you are not an expert in that domain, but surely you might want to read or consult experts in that team, in that domain, so that you have an understanding of what happens around or within their domain. So that as you implement what you want to implement, you're having an understanding of the specific industry or sector or asset class being modeled. Very, very important. Because what you are applying, you're applying a solution in a particular, you are generating a solution for a particular domain, which might not be your, you might not have expertise in that domain. If you are writing a journal paper, that's why we talk about co-authoring. And you're coming from the data science perspective, and someone is coming from the public health perspective, and someone is coming from that other angle, and you then combine effort and expertise in authoring an article. We can have this one, early detection of health issues through the analysis of electronic health records and wearable device data. There's computer science, biostatistics, sensor technology, there's data science, and so on. I'm saying this to emphasize that there's a we can do than just recycling topics if we can understand that data science research is interdisciplinary in nature. So you can look at predictive analytics for patient outcomes, algorithmic trading, climate change modeling, where you require a geography, data science aspects coming together, personalized marketing, where you require maybe psychology, statistical analysis, machine learning techniques, and so on. Let me come close to the formulation of a topic from a data science perspective, or even those from other domains can also benefit. A research topic must have what we call a variable. So I'm bringing to the fore components of a research topic. One of the key things that we want to look at is a variable in a topic, a variable in a topic. Because what you measure, what you study in any research is a variable. It's a variable that is measurable. So watch out, do you have a variable that you are measuring in your topic or that you are studying in your topic? Very, very important to take that home. So capture the variable of interest or the subject area, and this tells the reader clearly what you are writing about. And what you want to see in a data science research topic is the technique or the approach that you are applying or that you are leveraging. Just by merely looking at a data science at a topic, I can quickly pick that this topic is a data science research topic by seeing the technique or approach that you are applying. So you leverage an algorithm or a technology of the fourth industrial revolution and allow us to see it in your topic. And allow your topic or your research to occupy a particular geography or population. A well-formulated topic can point us to a particular geography or population. I heard the director, Prof. Chavundoka, talking about a sector, talking about a particular sector, and not necessarily maybe a single company. By so doing, you're pointing us to a particular geography or population. You are going also to discover that the topic must be linking seamlessly with your problem, with your research problem. Actually, you hear, if you were following closely, you heard the Professor Chavundoka saying, the point of departure, I'm amplifying it and I'm rephrasing it. The point of departure for any research is a research problem. And surely, sometimes it might be a problem, then you generate a topic, a very good way of doing things. You have a problem and you have a topic that links seamlessly with the research problem. So watch out for that. And in the new era of the institutions of higher learning, you hear them buzzing Education 5.0. And we are saying your topic must be Education 5.0 compliant. And which means there's a departure from the traditional community service lecturing and research, but an element of industrialization and innovation must be evident in your topic. So allow us to see that you are solving a real problem and you are complying with Education 5.0. Those are my submissions about the topic. And I want you to know that from the GBSC point of view, there are tired topics that we don't want to see, over-researched areas. I will just mention 4, and your supervisors will also help to say, this is a tired topic. We don't want you to be on that, or to be researching on that. So customer chain prediction, over-researched. Chatbot development, over-researched. Sentiment analysis, over-researched. Machine learning models for detecting cervical cancer, over-researched. So we want you to look for new areas so that there is that novelty in your research. You are contributing new knowledge to the universal body of knowledge. So watch out for these tired topics or over-researched areas. Let me, you see me emphasizing on topic formulation and on some of the topics that you can look at. And I point you to some of the emerging topics. Since you know that data science is constantly evolving and new research topics are emerging all the time, and we can be talking about privacy and security in big data. You want to agree with me that the issue of security, data security, has been there since time immemorial, and we cannot say it has ended. Surely we can do more. If you look at the convergence of security and big data, what can you do from that perspective? And you can have topics around data where we are having more and more data being collected, analyzed. There's need for privacy and security. Actually, the issue of privacy and security is increasingly becoming important. You look at machine learning for healthcare, where machine learning is being leveraged to improve healthcare in a variety of ways, such as developing new diagnostic tools, predicting patient outcomes, and personalizing treatment plans. So you can actually be having researches or research in that area, research topics in that area. Climate change is one of the hot issues in the present day environment in our times. As a data science student, can you do something to use satellite imagery, weather data, sensor networks to monitor and model climate patterns? And by so doing, we can see you helping issues around climate change. Can you do something about predictive analytics for extreme weather events, natural disasters, and environmental risk assessment? Can you leverage data science for sustainable resource management, renewable energy, and environmental conservation? And when it comes to computational biology and bioinformatics, can you do something to analyze genomic and other biomedical data to understand disease mechanisms? Can you develop predictive models for drug discovery, personalized medicine, and precision health care? Can you apply machine learning and data mining techniques to biological sequence analysis and large-scale genomics data? In urban planning and smart cities, can you analyze urban data, traffic, land use, crime to optimize city infrastructure and cities? Surely we can have our data science students also maybe contributing from this perspective. Why? Because we are hearing the language of smart cities, smart cities, smart cities. What can you do also to contribute with the data science research in that aspect? Predictive modeling for urban planning, resource allocation, and public policy decisions, integrating sensor data, geographic information systems data, and socioeconomic information for data-driven urban development. So with the geographic information systems and spatial data analytics, you can also even have research that you can undertake maybe in that direction. Integrating geospatial data, which is spatial, GPS, remote sensing with other data sources. And surely we can see you doing wonders in that direction. Spatial modeling and visualization for urban planning, transportation, and logistics. Predictive mapping for natural resource management, disaster response, and environmental monitoring. You can do a lot of work in that direction. Data mining for social media. And you see that we are having a lot of data exploding through social media platforms or systems. Surely you can develop new data mining techniques that can be used to extract valuable information from social media data. With also the noise around blockchain and blockchain, we can bring in the data science aspect into blockchain issues and actually make a contribution to issues around cryptocurrency, data, intelligent applications, and so on. Natural language processing, you can also do something in that direction. Customer segmentation for e-commerce, a lot of business is taking place through e-commerce systems and platforms. Can you analyze customer behavior, purchasing patterns to segment customers based on preferences, demographics, and buying habits? Can you still hear me? Do I still have students in class? I might be alone.
Yes, sir. We are here.
Okay. Okay. So you see, with this segmentation, you can actually be helping to tailor marketing strategies, improve product recommendations, and enhance customer preferences. And with a number of manufacturing plants also being installed, we are looking at the mining sector, we are looking at the manufacturing sector, we are looking at even waterworks, we are looking at even ZESA, we are looking at where we can actually have machinery being installed. Can you make use of sensor data from machinery to predict maintenance needs and prevent unplanned downtime? Surely if you can actually contribute in this direction, you are contributing to our society. And this can help to optimize maintenance schedules, reduce costs, and enhancing production efficiency. Healthcare fraud detection. So there's a lot of fraud that is happening. Maybe we'll also discuss with my colleague lecturers if we are still taking topics around healthcare fraud detection, because in the last semester I have students who were looking at medical insurance claims fraud detection. So, but there are topics that can actually be born out of this specific domain. Energy consumption optimization, I said something. Financial portfolio optimization. Can you analyze historical financial data to optimize investment portfolios? And traffic pattern analysis, I think we talked about this. Predicting disease outbreaks were hit by COVID, and of late were hit by cholera sometime, is it a year or so ago? And there's this other kind of flu that was also emerging from which country, by the way, I can't remember. Can you do something to predict these outbreaks? Building models based on artificial intelligence to predicting disease outbreaks, real estate market analysis, and so on, and application of big data analytics in GIS and geospatial data. And you can actually do in project management, data analytics, and so on. Let me be specific in a topic. A deep learning, let's have an example, one or two. A deep learning model to detect tuberculosis in chest X-rays for Zimbabwean patients. Remember, I said that there must be a variable to measure, And here we are talking about the tuberculosis in chest X-rays. So whatever we want to measure is about that. And what is the technique which align to data science or big data analytics? Deep learning. You're applying deep learning or leveraging deep learning in a deep learning algorithm. And did you scope or did you point to a particular geography? We are talking about the Zimbabwean patients. Surely this kind of a topic can pass the test of time. We can actually predict in children vaccine defaulting in Zimbabwe using artificial neural network. Where in Zimbabwe? What? Vaccine defaulting in children, and which technique? ANN. So we can actually have more of that. We can actually be talking about deep learning model for multi-drug resistant prediction in TB patients, case of Paranyatwa Hospital. If you can actually have a large data set, complex data set, that can actually help you to address this, to develop your model. Deep learning, multi-drug resistance, and in which kind of people we're talking about? TB patients, so that we know that this is your population that you are dealing with. Very, very important to have those pointers. In terms of electricity, electrical energy fault detection using supportive vector machines, and in the context of Zimbabwe Electricity Supply Authority. And you see that all the components that I'm talking about are there. I supervised a student. We had the topic predictive maintenance of ball mill grinding machine in the mining industry using machine learning. So we see this also happening. Now, I don't want to spend a lot of time maybe talking about the background to this study, but I want you to take note of this when it's a data science research. And I will be using the example of detecting tuberculosis or TB in chest X-rays. When we come to your background to the study, we want to see our students or my student doing this kind of research over and above giving us the historical facts and statistics around the variable of interest. We want to see you showing the shortcomings of the traditional or current systems of detecting tuberculosis in X-ray in chest X-rays. So when I'm going through your background to the study, I must be able to conceptualize that indeed there is a problem with the traditional or current methods of measuring or detecting or predicting TB in chest X-rays. So when we see those shortcomings, you then bring in the value proposition of whatever technique that you want to apply. Maybe in this case, it's deep learning. You cannot say you are done with your background study to the study without showing the value of machine learning, the value of deep learning when it comes to detection of maybe TB in chest X-rays. So I want you to take this home. Make sure that wherever you are carrying out your study and you are suggesting use of a cutting edge, maybe technology, AI, machine learning, reinforcement learning, allow us to see the shortcomings of the traditional or the current methods, so that we then see the value of the technology or the technique or the methods that you are proposing. I hope you are taking this. In the context of a problem statement, I was going to give you maybe a minute to go through this one and see that if you are still carrying forward that research around the detection of TB, we would then want to see in the problem statement that indeed there is a real problem. And maybe it's even documented by the World Health Organization, which is an international authoritative body, which is talking about TB being a major public health concern in Zimbabwe, with an estimated incidence rate of 220 cases per 100,000 population in 2021. Surely that points to a real problem, and it's a current problem, and it's a problem that is affecting our local communities. But from a data science perspective of defining a problem statement, allow us to see that their current methods, traditional methods that they are using, and they are having certain limitations. And you see there is a statement to that effect. And you want to see that there are problems with interpretation if you are using a lot of manual methods or human where we are seeing the human factor doing much of the work in terms of detection and interpretation. So this then brings in the need for you to say what is an ideal situation. And we see you maybe talking about machine learning or artificial intelligence or whatever, maybe technology or solution that you are bringing to the fore. Now, I want to mention something again in the research objectives, when it comes to a big data analytics kind of a research. So we talk about you having the overall research aim, which applies across the every kind of research, where you're having an aim as the overall purpose of your research, written in finite form, where we are saying maybe when you say you are adding the word to in front of the verb, which means it's a very good way of doing. The aim of this study is to develop and or is to generate or to do this. And if you do that, and in your objective, this has been emphasized. Allow me to say, in your objective, we see an active verb. we see a variable that you are measuring. Because when we're talking about the SMART model, SMART, we are talking about a variable that is measurable. A variable that is measurable. You are specific on the variable of interest, and that variable of interest is measurable. So allow us to see that I've seen objectives where students they don't have a variable to measure in an objective. So take that home to say there's a variable to measure, and allow us to see the algorithm or the technique that you are using, so that if I pick a single objective in isolation on a piece of paper, it's communicating the full story about the variable to measure and what you are doing in terms of the verb and the algorithm that you are applying and so on. And I'm telling you, you do this, you are having a complete research objective. And there's one thing that I also emphasize, and we emphasize as a school, we say there must be logical sequencing of objectives. It's not mun afane kumedza kutsenga kuchada. Mun atitendere kuti munhu atange nekumedza asati atsenga. First things first. Surely, and you see in the example that I'm going to give, and I see many students having this kind of an error. Now, let me give you an example of we are still carrying forward that research topic to do with X-rays. So the first objective could be to ascertain the relevant features in chest X-ray images that aid in the diagnosis of tuberculosis in Zimbabwean patients. So to ascertain, active verb, and to ascertain, that's the verb. And what is the variable of interest? Features in chest X-ray images. That is our variable that we are measuring. Though we can actually go on to say this is pertaining the tuberculosis patients, and this is to do with the Zimbabwean patients. And number two, then you are developing maybe a DenseNet 1-to-1 model to detect tuberculosis in chest X-ray images for Zimbabwean images. Now, you then see that what are you doing? You are developing. What are you developing? A model. And what kind of a model? It's a DenseNet 1-to-1 model, which is a machine learning model, a deep learning model. And what are you doing? You are detecting tuberculosis in chest X-ray images for Zimbabwean patients. Number three, you are evaluating the performance of the model that you would have developed in number two. And I have seen students starting with objective number two to develop a model. Then I see them talking about the features that are used to develop the model. Yet we say first things first. What comes first? Surely ascertain the relevant features in chest X-ray images, because you are developing a model based on these features. How can you start with developing the model, then you talk about the features? This is what we talk about when we say logical sequencing of objective. Features, develop the model, evaluate the model. Surely there's a flaw that is reflected that way. Now, significance of the study has been covered to practice or industry, to society, to government policymakers, to theory. That has been covered. In terms of delimitations of the study, the conceptual or theoretical scope, what are the concepts or theoretical variables that you are studying? Geographical scope, you are delineating the geographical boundaries. Your research starts from this to there in terms of boundary. And the time scope, you also delineating the time scope. Let me zero in quickly on literature review, few components that you need to add. Now, I've seen data science students having the literature review section is the same as any other research that is being conducted in public health, maybe in medicine, maybe in strategic management, maybe in the supply chain. Now, we want you to know that we want to see the data science, the big data analytics fabric in your literature review. It must reign supreme in your literature review. Now, we agree, I can agree with you that as we start the literature review section, you are starting with the theoretical literature, where you had Professor Chavunduka talking about the concepts, the major concepts of your study, the major variables of study, and even the variables that are encapsulated in your research objectives. We see you providing or collecting and reviewing literature around those concepts in what we call theoretical literature. And surely we see you mentioning and reviewing the theories underpinning your study. And then we want to see you making sure that all the themes emerging from your research objectives are covered in terms of literature collection and review in the literature review section. And you heard them talking about even the empirical literature, which we can also call related working, where we are seeing some have developed the models around the tuberculosis, maybe using chest X-ray images, maybe in Kuwait, maybe in Baghdad, maybe in Ukraine, maybe in Gaza, somewhere there. We see them. They have developed. They have done work that is related to what we are specifically studying, and want to see that empirical literature or related work. And then we can have a research gapping so that we see that you are contributing to the investor body of knowledge. And I want to say, I've seen our students, when we say we come to the theoretical literature or to the theories underpinning the study, they are talking about a data science framework. No, that's not what we want. That's not what we want. That's not what we want. Let me give you an example, a quick one. Let's say maybe you are developing a model. Is it around disease, maybe outbreak prediction and so on? We know that you're a data science student. We know that you're a big data analytics student. But there's a theory that informs your area of study. In this case, it can be the germ theory of diseases, and by Lewis and Robert, who proposed a germ theory in the 19th century, which laid a foundation to understanding of the causes and transmission of the now called non-communicable or infectious diseases. Surely, that's the theory that we are talking about. We're not talking about anything that is specific to data science. The theory, the area where you want to implement data science tools or methods or techniques, there's a theory proven and tested in that area. In this case, the germ theory. Because remember, when you're building a model, and you require features, and this theory is informing you to say, it helps you to identify the germ theory. It helps you to identify the causative agents of infectious diseases and how these causative agents are transmitted. And whatever model that you are building, whatever model that you are constructing, is around these causative agents or the features or anything of that nature. Surely you need a theory underpinning your study in that particular domain. So take note of this. We are not talking about crisp DM. We are not talking about team data science as your theory in this thing on this area. So we have seen students making a lot of mistakes and they are jumbling things and so on. So we are saying on your literature review, make sure that when it comes to deep learning, give us literature around deep learning. Give us literature around the deep learning models that have been developed around in the domain of study, or in measuring or studying the variable of interest. Let's have that content, a lot of that content, so that you reflect the data science fabric in your research. Otherwise, it will end up being a public healthy research if you are not bringing in the big data analytics, the data science, the machine learning, and so on, the deep learning, the reinforcement learning aspects around your variable of interest. I hope you are getting me. Surely, issues of authentic literature has been mentioned. Using recent literature, contemporary literature has been mentioned. Surely, take that home. Confirm we are still together. Before I move on to key issues that apply to data science in terms of the research methodological aspects. Are we still together?
Yes, sir.
Okay.
Yeah.
Now, I want you to understand that research, data science research, there are frameworks that help you to structure your methodology. It's not akin to the ones that we can have maybe from strategic management, supply chain, social sciences, and so on. You can make use of frameworks that speaks to a data science research. And we talk about frameworks. I know that we're talking about CRISP DM, which is cross-industry standard process for data mining. We have the knowledge discovery of databases, KDD. We have the team data science process, TDSP. We have the AWSOM, OSEMN, the AWSOM, which talks about obtaining your data, scrubbing, exploring, modeling, and interpreting. So it's giving you a pipeline. This framework is giving you more of a pipeline that you should follow from obtaining your data and working with your data and modeling based on your data and then interpreting your results. And I've gone the breadth and depth of literature to add more, because in the SIS we're talking more of these four, and also even maybe DSR, data science, research maybe as a philosophy or as a design that you can also leverage on. We can also talk about the phases, which is the feature engineering, algorithm selection, cross-validation, evaluation, and selection. And it's best remembered by put on your best phases for machine learning. Put on your best phases for your machine learning. So you have the pipe, which is problem definition, information gathering, pre-processing, and evaluation. So we have this CRISP DM, AWSOM, TDSP, KDD, and so on. Maybe we can zero in juicy on business understanding, because when you want to address a particular problem, you want to understand the environment. You need to understand the business within which you want to implement your data science solution or application or model. So have an understanding, and this even stretches to understanding the problem in the context of that business environment. And then you go on to data understanding, where you then need to understand the data, and we're talking about the data set and the variables involved and so on and so on. And data preparation, surely you need to go through the data wrangling process. And we say in data science, 80% of your time goes to data preparation and 20% maybe to creating the visualizations and the analytics output. But otherwise, 50 to 80% goes to data preparation, where you are making your data amenable for analysis. Very, very important to take note of that, and to make sure that you are giving the attention that data preparation deserves. And we then go to modeling, where you are then creating the actual, you are creating the artifact. You are creating the artifact. Then maybe it's a model, maybe it's a dashboard, maybe it's an ETL, maybe it's an intelligent, maybe it's an application, intelligent application, and so on. We want you to create the model. Create the model, you are creating the model. But when you are in the methodology section, you are not creating. Professor Shavundoka rightfully said, here you are documenting the procedures of how you are doing it. So in this case, you are not actually, how did you develop the model, or how are you developing the model? So you give us the procedures, the techniques, the methods, the tools, the techniques that are involved. That's what you want to see in the methodology section, not the actual artifact. Data preparation, how did you do it? Data understanding, how did you do that? How did you achieve data understanding? Evaluation, how are you evaluating the performance of your model or your application or your system that you would have developed, or your algorithm that you would have developed? You are not actually doing the actual evaluation. But here what's happening, what metrics are you using and procedures that you are using to evaluating your system, your model, your application, your algorithm? So you're documenting the evaluation metrics, because surely in data science, we want to say you have developed an artifact. Is it performing? And then that's when we talk evaluation, and then we can come to deployment in the real world, the deployment of the artifact that you would have developed. I've explained the CRISP DM because in any other data mining framework, you see maybe an overlap in terms of these concepts, and there is data collection, there is data transformation, preparation or wrangling, and there is evaluation, there's deployment. And like I said in my previous slides, I said you can also even out my paper data wrangling. I documented nine of those steps that you can actually take if you want to generate a new data set. Let's zero in on the choice of an algorithm. Choice of an algorithm. Now, this is very critical. Very critical. And I'm using examples of machine, saying it's a machine learning problem that you want to address. And if it's any other problem, you then know what kind of a problem are you trying to address, and which kind of algorithm are you applying or using. I want to quickly say, any problem that you are addressing from a data science perspective, you want to ask yourself a question: is it a classification problem? Is it a regression problem? Is it a clustering problem? Is it an association problem? Is it a dimensionality reduction problem? Is it a prediction problem? And this informs you of the algorithm that can suit the problem that you want to address. Like, you then know that supervised machine learning are very good when it comes to addressing classification problems and regression problems. Because sometimes you might be forcing a particular algorithm to solve a problem, to solve a different problem which it was not designed for. And on classification, you can talk of your decision trees, you can talk of your support vector machines, You can talk about your linear classifiers. You can talk about your k-nearest neighbors. You can talk about your random forest, gradient boosting. You can talk about neural nets. You can talk about naive Bayes classifiers. Regression, you're talking about logistic regression, polynomial regression, linear regression. Those techniques that can actually help you to solve a regression problem. And when it comes to unsupervised machine learning, because you want to solve that kind of a problem, maybe it's a clustering problem, you then make use of the k-means clustering algorithm. Soft k-means, Gaussian mixture model, and you're solving a clustering problem. So association, maybe it's a priori algorithm, FP growth, and so on, which you can make use of to address an association problem. And I did say, as one of your objectives in data science research, you can be generating a data set. And it is that data set then that you use to develop a machine learning model. Or maybe you download a data set from Kaggle or from GitHub or from an online repository, data repository. You then discover sometimes your model maybe is not performing to the level that you're expecting. Why? Because not every variable is contributing to the best performance of your model. You might want to engage in dimensionality reduction. We talk about feature engineering, we talk about feature selection, we talk about feature importance. I've also written work in this direction, even on that paper and other papers of 2023. You can Google them on Google Scholar by my name. You see also 2 papers which I have written on feature engineering and also even machine learning, on machine learning. That can also help you and other articles that you can come across on the internet. So you can also even use, we cannot call them emerging, they've been there for some time, but we are seeing students only concentrating on the classical or traditional machine learning algorithms. We want some of you to be leveraging reinforcement learning, which is a computational approach for learning from action in the absence of a training data set. And we are saying with this kind of an algorithm, you can actually be able it stocks the environment, and then it will be giving feedback. And from that kind of learning or that learning experience, which means it can be rewarding positive actions and the negative ones are being punished and the positive ones are getting rewards so that the system is improved even for future predictions or classifications or clustering. So you can also maybe even leverage reinforcement learning, transfer learning, which is also the reuse of pre-trained model on a new problem. So in transfer learning, what are you doing? You're exploiting the knowledge gained from previous tasks to improve generalization about another task or another problem that you're addressing. So I've talked about these machine learning algorithms, and we have covered those ones, and even the supervised and unsupervised and reinforcement learning. And by now, I know my students know that supervised learning, it works with the labeled data. Labeled data, maybe have a target class where you're saying, maybe the papers that I have written, we are measuring medication adherence amongst non-communicable disease patients. And I can say the target class I have labels to say is adherent and non-adherent. That is the target class. So it's labeled because a prediction falls either in the adherent class or the non-adherent class, and supervised learning algorithms suits that kind of a scenario situation. And supervised where you have unlabeled data, which means it can actually help you to cluster based on the patterns the algorithm is picking from your data. And surely anomaly detection, association rule mining, clustering, you can run with unsupervised learning. But if you want to prescribe the action for new system state, then you can actually go for reinforcement learning. And regression, you want to know that so when you're targeting output is a continuous variable or value, so the task is a regression, and you see that you want to use a machine learning algorithm that addresses a regression problem. And by the type of data, when it is like this, then you know that a regression algorithm suits this kind of scenario. So even in classification, you want to know, is it a binary classification? Where I said non-adherent class and adherent class, which means that calls for binary classification. Or maybe you're talking about multi-class classification, which means maybe you're having more than two, between two or and so on. And also even in another thing that I actually left out in terms of the machine learning algorithms, you can actually be using ensemble learning. Ensemble learning, another variant of machine learning, which combines the prediction of multiple machine learning models to produce a more accurate prediction. What is happening? You are twinning two different algorithms. You are having more of a hybrid, which we call an ensemble classifier, which means you are taking the power, the strengths of this algorithm, the SVM algorithm, and you twin it with the powers or the strengths of the random forest, and you come up with an ensemble learner or an ensemble classifier, and you are producing maybe better results. But at the end of the day, the best prediction is what you require from your research efforts or from your efforts. So we talked about clustering, anomaly detection, association rule, dimensionality reduction. Sometimes you're going to see that it's not every variable that is helping the cause of improving the performance of your model. So you might want to engage in dimensionality reduction. Feature selection, you then exclude features that are not aiding the cause, and you then use those specific features that are improving model performance. You do it very well, you see then that you are going to engage in dimensionality reduction in one way or the other. Even if you have downloaded a data set from Kaggle, from GitHub, from Mendeley data, maybe it's not giving you the best results. Engage in dimensionality reduction. And if you are to apply a regression algorithm, is it linear regression? We are predicting a continuous output by modeling a straight line relationship between input features and target variable. Is it logistic regression? Yeah, models the probability of binary outcomes. Polynomial captures a nonlinear relationships. Time series regression predict future values in a time-dependent dataset. Support vector regression, SVR, approximates a continuous function by identifying a hyperplane that best represents the data structure valuable in various applications, including financial market prediction and so on. Let me zero in on acquiring and generating a data set. You can actually be able to access a data set on what? On Kaggle. There are many of these online repository of data. GitHub, Google Dataset Search, DataGraph, DataHub, Earth Data, Global Health Observatory Data Repository, FBI Crime Data Explorer. And if you remember in earlier slides, I said you can also even make of Mendeley data
I actually contributed to the Investor Board of Knowledge by generating a data set using the local situation, the local environment, and I've added a data set on that one. And we are saying you can actually make use of these data sets, even sometimes if you are having a challenge of accessing maybe those that are paid for. But we want you also to say if you are solving a local problem, generate your own data sets. If you want to, if we are to emphasize on novelty, we want to see you making use of locally generated data sets. And surely you will not have a challenge of saying you're contributing to the Universal Board of Knowledge. Let's talk about the data analytics pipeline. I think we have talked about this one. In one of my paper of 2023, you then see that if we are to pinpoint some of the things that you need to take note of in the data analytics pipeline, surely you need to identify your data source. And your data source sometimes, is it historical? Is it historical secondary data? Is it electronic data generated in real time? We are talking about wearables, the wireless, what do we call them? The wearables, where you are having a device inserted on you, or it's clipped on you, and maybe it's sending data to a particular server, and you are getting that data. It's happening a lot in health, in the medicine domain. So it can be primary data and so on. But I want you to take note, this data can be IoT data, video data, it can be audio data, it can be pictures, images, it can be that kind of data. It can be structured, it can be unstructured, same structured. You need to know that. Primary data through interviews, observations, and experiments. But I want to hasten to say, when it comes to artificial intelligence applications and models, they do have a high appetite for big data. So you want to make sure that are you generating big data from your primary data collection methods, interviews, observations, and experiments? Are you having big data at the end of the day? Because you want to have enough data to train the model that you are developing, and then you have another set 20% or 10% of 15% or 30%, which you then use as your test data to evaluate the performance of your model. So take note that whenever you are developing these applications and models, artificial intelligence, machine learning do require big data. Now, after identifying your data and you collect a data source and you are in pre-processing and feature engineering, acquisition of data libraries, and you are importing your data library, importing your data, you are splitting your data, and so on. And if it requires some sign-offs and approvals, you would have maybe gotten approval to make use of the data, to make use of the data set. And you are also involved in EDA, exploratory data analysis, visualizing the data, handling missing data, handling outliers, checking assumptions, and so on. And then feature engineering, you are splitting your features sometimes, and you are categorizing you are merging some features and so on. You are engaging in categorical encoding, because you are going to see that out of the box you cannot make use of some of the categorical data. You need to encode this data so that you make it amenable for use in machine learning modeling. Or maybe you are then going into variable transformation. We talk about feature scaling. If it's numerical data, sometimes the data has a lot of outliers, low values, middle values, and so on, and you want the data to be in the same range through numerical scaling of the data, numerical scaling of the data, and so on. Then we talked about the machine learning approach that you are using, and you are splitting your data for training, and then for testing, and by so doing, you're building your model, and you then evaluate. I think this is a more specific one that I want you to also have a look at. And we talked about that in knowing that this is applied research. It's different from sometimes those ones that are done from strategic management, supply chain, social sciences, where they engage in basic research. Ours is applied research because at the end of the day, you want to present an artifact. I think I drove the point home when it comes to presenting an artifact at the end of the day. So let me zero in. I'm almost in the twilight of my presentation. What are the skills required to be a data science researcher? Surely statistical skills, and we have exposed you to some courses and even courses before you joined us. Analytical skills to analyze and test the data. Programming languages is a must. Python, R, MATLAB, Java, and any other data science tools that you can make use of. Data visualization tools like Power BI, Tableau, or you can actually do a lot of good visualization in R, in Python, and so on. You can actually make sure that you are in the know and you are conversant with some of the algorithms that you are leveraging. Are they regression, classification, and association, and so on. And have good communication and presentation skills. Sometimes if you are to engage into data staging, data transformation and staging, and spooling maybe from different sources where you're doing developing ETLs, and then do data staging, and then and have the data into your SQL or Oracle or whatever before you suck the data into a visualization tool, which means you need to have the knowledge maybe of Oracle or SQL or whatever data management system that you are using. And you can also have skills, cloud computing, to manage your resources. Sometimes you are saving your data, you are saving your work in the cloud, and sometimes you're accessing cloud computing resources that are hosted in the cloud. So you have that one. Tools, you're going to be using Python, or you're going to be using R, you're going to be using MATLAB, you're going to be using statistical analysis system, SAS, you're going to be using maybe Stata, you're going to be using IBM SPS statistics, maybe and Amos, and so on. If it's able, you're being able to address it. Like you can run a k-means, you can do k-means class analysis in SPSS, and so on. Power BI for visualization and even for some analysis, and Tableau, Excel, if you can go the advanced route of producing models, and so on. And you are going to be making use of the integrated development environment or the code editor, which can actually be helping you to say when you're writing your code, it helps you even with the corrections and so on. So you can be you're having Python as your underlying software, but on top of it, you are making use of the IDE or the code editor to write your Python code. And it simplifies coding because there's the intelligent feature and so on, and the errors and so on. You can quickly pick the language and so on as you type. You can make use of Jupyter Notebook, the popular one this side of the world, even Visual Studio, even Spider, even PyCharm, Tony. Actually, we have many of these, tens and tens of these, if not hundreds of these ones. We can make use of these IDEs. You can also make use of libraries, which are bundles of codes, so that you are not writing a code from scratch. You are making use of libraries. Let's say you want to build a machine learning model, or you are wrangling your data, pre-processing your data. You are in data dimensionality reduction, and so you want to make use maybe of existing libraries. That makes your life easier sometimes. Unless if you are to develop, you are to write your own code, and you bundle it into a new library, which we can then benefit from in the data science community. Pandas for for manipulating data, structured data seamlessly. So you want to import data into Python, surely use pandas. You want to do certain manipulations, you can be using pandas. NumPy for multi-dimensional arrays and matrices, along with a collection of mathematical functions. You can use the NumPy library. Matplotlib if you want to do some plots in Python, maybe the AUC curve, maybe the confusion matrix, matrices, and so on. You might want to use the Matplotlib for plotting, and this can be static, interactive, or animated visualizations that you make based on Matplotlib. Seaborn, another one which is built on Matplotlib, which provides a high-level interface for drawing attractive statistical graphs. You can make of SciPy, TensorFlow, Keras. If you want to develop neural nets or deep neural nets, you can make use of TensorFlow and Keras. Scikit-learn if you want to do statistical and machine learning models. Bundles, of course, that are already at your disposal to do this. PyTorch, Dash, and other libraries. There are actually many, and all that. Now I'm five slides before I'm done. 5 to 6 slides, and references. This has been highlighted, and we are following APA, and you do this religiously, both in text and on the reference list. On the reference list, referencing is a must if you are taking your some of the work from somewhere. Surely acknowledge the sources. And I didn't say in chapter 2, your literature review, you can need to go for main lines without referencing. Surely, how can you have a paragraph without references? And we want to see you having a lot of in-text referencing, especially when it comes to your literature review and also your background to the study, because it's embedded in existing literature, existing facts and figures. We are obtaining them from existing literature. So we see you referencing in text, we see you doing it even the reference list, and you are following the APA religiously. And you can make use of a software to organize your sources. And take note, you can actually make use of EndNote, you can use of Zotero, or the one which is popular this side of the world, which is Mendeley. A data science student, surely make use of a software. Don't do it manually. Invest time to learn about this software so that they help you to organize your work. In terms of structure, it has been emphasized that though maybe there's a lot of technical stuff or work from data science perspective, but make sure that you are following the cut house style religiously. That has been hammered by the director, Professor Shavuntoka, and Professor Sefile. And make sure that you cannot afford to sleep on duty when it comes to following the cut house style. And formatting, we are not, you get it from the cut house style documentation guidelines. You take the format from there. But I have a problem with the students from data science who have a document that is not well formatted. You deal with computers every day, you deal with the data every day, you write reports, you do analysis, and your fingers are intelligent, your hands are intelligent. You still see a student with work that is not justified on the right margin. There are inconsistencies in line spacing. I don't expect that from a data science student. Make sure that your work is top notch. The presentation is top notch in terms of formatting. Surely we are not exonerated. You are not exonerated. Especially if you are a data science student, we expect you, even a master's student, a postgraduate student, your work must be top-notch, highly well presentable, and so on. Let me zero in on some of the do's and don'ts. we say do locate or prepare a dataset to use. We say as you are submitting your concept note or your proposal, make sure that you locate the dataset now, because this is a very important component of you undertaking the research. Sometimes you see that somewhere there is maybe 2 months down the line, 3 months down the line, you don't have the data set, you want to restart again. So make sure that you locate the data set, or you are generating a data set, and you are sure that you have a data set to use. Otherwise, it will be disaster. Do invest in programming and visualization skills. Do systematic work, because research is carried out in a systematic and organized manner. And we say cut house style, and cut house style. Don't claim precision where it is not justified. These are ethical issues. Surely reporting what is coming out of your model, your machine learning model, or your artificial intelligence application, or your intelligent application or agent, reporting what is come out. Precision must not be, precision must be reported as is. Is it 85%? Is it whatnot? As is. Don't present a conjecture as a fact. Don't plagiarize. Don't use AI-assisted writing. And we'll catch you, and if we do not catch you, you are dealing with professors, you are dealing with doctors, you are dealing with academics, you are dealing with lecturers who are good in this job, year in, year out, even without subjecting your work to anti-plagiarism check, I will tell you, we can pick the thread to say this is AI-assisted writing. Don't falsify records or cook up data. The data science fabric must be evident. I emphasize this one. Don't have your background to study, you divorce your study from the data science fabric. Don't have your literature review, you divorce it from data science fabric. Your topic, your research topic, your problem statement, your background, your objectives, your literature review, methodology, your results. We are following a thread, a golden thread, plus the data science fabric must be evident. Your end result must be an artifact. I think I have sucked you in enough to know that what we need is an artifact from a data science research or big data analytics research. And they just follow the cut house style. I think I've done that one. I think this is the end of my presentations. I can take questions.
Thank you, sir. If I can just ask.
Yes.
So what I'm getting is when we submit the dissertation, are we submitting it together with the PICO files and the data sets, or it's just results? Thanks.
Okay. So you talked about the document, the report, and you talked about the data set. What else? What was the third thing?
The PICO file or the notebook.
Or the notebook, yes. So, because sometimes we want to in data science we talk about the veracity, the other V of big data, isn't it? We want to check authenticity on the authenticity of your data, authenticity of your work. Sometimes we surely you should have that. If we're asking for that, it's at our discretion. But the student should have the report. The student should have the data set. The student should have the code. Should have the code, whether it's a notebook or whatever file that you are having. Surely have that, because we can ask for that as we comply to the other V of big data, which is veracity. I think I've answered you, unless you are not answered.
Answered, sir. Thank you.
Welcome. Any questions? I can take questions.
Hello, sir.
Yes.
I wanted to ask on the issue of data sources. You mentioned Kego and other various data sources. I'm not sure how would those be relevant? Suppose the question is, or the dissertation is to develop a model that will be used locally.
Okay, so I think I actually touched on that one when I said I was giving you to say sometimes we're solving global problems, and some global problems connect to our local problems. But I think some of you heard me saying we want you to solve local problems, and we want you to do your best to make sure that you get access to local data sets. It might not be a prepared data set. You get raw data. And it might not be from one source. It might be from source A, from source B, from source C. And you then engage in data integration and enrichment so that you have your data set. To some of you, it might be your first objective, objective number one, where you are generating a data set and there is integration of different sources and there is enrichment of the data and there is transformation of the data even, and there is splitting of some features and there is aggregation of some features as you create your own data set. Surely we'll be happy if our students are using or are generating local data sets to address our local problems. I'm not sure if I've answered you.
Yes, you have answered, but I think I've got a follow-up question. Let's take, for example, you said some of the models, they require huge data sets for them to generate results that are meaningful, to have better predictability. But in our instances, I've just been doing some preliminary research on data sources. You rarely get data sets that have got more than 1,000 rows, and some models, they require tens and thousands of rows. In Zimbabwe, data sources are a bit of a challenge. Take, for example, just one industry where you may not get data sets that are in one place and are probably structured. Real estate, for example, you rarely get a stockpile of data where you get the price of a house or the price of a property together with the features of the property all in one place. You rarely get that. But there's a relevant or there's a problem there to be solved using probably machine learning models. I think that's a bit of a challenge. I don't know. When you're saying generating data, is there something that can be done to generate data?
Generate a data set. By generating data, I'm talking about generating a data set. And so maybe I can say when you are talking about real estate data, sometimes there are many sources where you can get about maybe how prices, maybe advert on the internet, which means it's something that can take you maybe 2 months or so generating that data because they are posting that data on websites or maybe social media and whatnot. So what are you doing there? Maybe you are then generating data from different sources, price, weight, location, and so on and so on. Surely we end up having a student having more than 10, 12, 15 variables sometimes. I know it's not easy, but it's doable. Very much doable within 6 months, if not 3 months or 2 months. That's my first response. My second response, I'm telling you, sometimes is about, do you have access to a particular company? And then you are able to convince them that this is for academic purposes. You are then assuring them that you are anonymizing the data, that which we call data IT identification. Because sometimes surely data, when you are given the data, even we can do it with the IT, to say before I take the data, we can have an internal person where you de-identify the data and you have it. That data will will not have any negative implications. So that's another way of winning, of winning in that direction. But I agree with you, it's not easy to get a data set. But this is something that we need to work on and do our best to make sure that we have a data set to use.
Okay, thank you, sir.
Welcome. And Nematire, another thing, I want you to know that if you research further, you then understand that there are case-by-case issues that we address as supervisors. You might not get a data set with 20,000 or 10,000. You might get a data set maybe with let's say with 1,000 or 1,500. And you might have, maybe you get that data from somewhere, maybe from CMAS, you get the same data with the same variables from there. You can also even data integration. I mentioned about data integration. Number two, you want to understand the issues of cross-validation and hyperparameter tuning, which can help you to say, when your data set is small, there are some things that you can do in the machine learning pipeline which make it usable if you can engage in cross-validation and hyperparameter tuning. I hope you understand. You are following.
Yes, I'm following.
Yeah. So there are other routes there which we can then also follow.
Okay, sir. Then probably my last question is: suppose we need to approach Cambo to secure data sets. Is there any documentation that we should expect from assist us in getting, probably easily get the
Research team, you can answer that one, or Prof. Chavunduka if you are still in.
Among the templates you are going to receive, there is a document there which will assist you to do that.
Okay, thank you, sir.
Yes, I think we need to be closing. Any questions?
Maybe just a compliment. Just to say, when you came in, it helped us because, like, the first impression was we have just to follow the traditional way of doing research. But when you came in to show us now in data analytics, sometimes you want to do a project, you want to implement a solution, which might not be like it has been highlighted before. So thank you so much. Actually, you clarified some of the questions that we were having.
Thank you so much for the compliments. Any other issues before I hand over the closing session time to Timbe and Prof. Chavunduka? Seshi Timbe, say it's your time.
Thank you, Mr. Kanyongo, for a well-articulated presentation. I hope the students will take note of what you have presented on. And my worry and concern is on those students who didn't attend this session, how they are going to do a data analytics research if they have missed this important session. I, however, hope that they are going to do some playback, and those who are present will sound the bell, or those who did not attend, how serious the data science research is. We thank you, Mr. Kanyongo, for the presentation.
You're most welcome. Thank you, Seshi Timbe.
Prof. Chavunduka, are you still there?
Yes, indeed. A wonderful presentation. I was following. I enjoyed it. I picked a few issues that I'm going to follow up in my own researches. Thank you, Mr. Kanyongo. Please accept our sincere gratitude for your commitment and for the elucidation of the various issues, particularly relating to big data analytics.
Thank
Students, thank you very much. Thank you very much. Wonderful team. I also like your commitment. I'm hoping that you are going to make good use of the issues that have been raised through this discussion. Please let me emphasize that you use the guidelines. Mr. Kanyongo has emphasized over and over again. Please use those guidelines religiously. Yes, we are going to give you this particular presentation on your various platforms and make good use of that. Work consistently, begin now to embark on this journey, avoid unnecessary delays, also avoid plagiarizing, avoid overuse of artificial intelligence. Please keep on to timelines. Otherwise, it's my honor to say thank you very much, all of you, for attending. I wish you well on this journey. Let's meet in cyberspace. Let's meet very soon as we also do the data analysis workshop. We may be inviting and requesting Mr. Kanyongo to do the data analysis, or Dr. Masam. I'm not sure which one is on the cards, but thank you very much, all of us. I want to wish you a good the rest of the day and a good journey on the dissertation guidelines. Thank you very much. Bye-bye.